In this video, we will discuss propagation loss modeling of wireless links. We have done a previous video demonstrating complex wireless system using emulation, and you can find that on Louis' website or at the link on this slide. Wireless link modeling is complicated or complex because of physical and environmental issues. Link can be interfered by vegetation or environment like forest environment, or it can due to weather such as rain, cloud, fog, and other weather conditions. Or if you in an urban environment or rural environment, the effect of the model would be different. There are also link factors such as distance between the transmitter and the receiver, or the speed that the object is on, and the transmit power, receive sensitivity, or the operating frequency, or if there's jamming being introduced into the link. The model would be different. The demo that we'll show you next use a moving vehicle and a stationary object. It illustrates the link physical models in dynamic emulation systems.
In this demo, we will be using the system configuration shown in the diagram. We have a Windows laptop acting as a wireless client, which is connected to the wireless gateway through Wi-Fi link. Now the software block diagram is shown below. The propagation loss model program is also run on the host system same as that of a gateway. This program calculates the propagation loss at regular intervals and applies it to the wireless link between the client and the gateway. In this simulation, the client will act as a transmitter while gateway will act as a receiver. Now I will switch to the host system to start the wireless gateway. I will start the gateway using server IP and the port number of 12,000. Now in the second terminal window, we need to run the packet loss simulation program. This program takes three arguments: the wireless interface name, the port number on which the client will be connected to the server, which is 12,000, and the update interval for packet loss, which we will be setting it to the 1 second, so that every 1 second the new packet loss will be calculated and applied to the Wi-Fi link.
But that the user can change, right?
Yes, the user can set the update interval while starting the packet loss simulation.
Okay.
Now, in the program, first we need to select the packet loss simulation model. In user-controlled model, we can manually select the value of the packet loss. In random model, the values for the packet loss are randomly generated between the specified range. Now we will run the third model, which is a propagation loss based model, which will use the propagation loss modeling to calculate the appropriate packet loss.
And that's based on the ITU model?
Yes, it is based. It is modeled using the ITU models as well as some other low frequency models such as Okumura-Hata model. Now, for this model to work, we need to enter the specifications of the communication link between the transmitter and receiver, starting with the carrier frequency, which we will set to 28 GHz. Now we can select the simulation environment. It could be urban, suburban, or open or rural environment. We select suburban. We have also added the attenuation due to weather effects to be applied to the packet loss. We can select either rain or cloud. We will select rain. Now in rain, we will enter the millimeter per hour rain. Then some other specifications related to the rain attenuations are required. Then we need to enter antenna specifications. That is the antenna heights of both transmitter and receiver. So we'll set base antenna height to be at 100 meters and the mobile antenna height, which is basically the receiver height, to be 1.5 meters. And the transmit power will be set at 30 decibel meter, and receiver sensitivity will be set at -100. Now these specifications can be changed as per the user requirements.
And because we want to illustrate the functionality, so we want to show all the details. But
So once the specifications for the communication links are provided, the program automatically calculates the link budget, and it creates a table for the user for different packet loss and the corresponding link distance. Now we can run a live simulation of a receiver traveling towards the transmitter base. We can select the starting distance of the receiver from the transmitter. We will select it to be 4 kilometers. Then we need to enter the relative speed of the receiver. In kilometer per hour, we will set it to be 120 kilometers per hour. Now our simulation is ready to go. Now I will switch back to the client. Now on the client system, I will switch to the browser where I am running a video on using the wireless gateway as a proxy server. Now at the same time I'm also capturing the TCP packets being transmitted between the wireless client and the gateway using Wireshark. Now I will switch back to the host system and start the packet loss simulation. Once the simulation is started, the receiver will be at the 4 kilometer distance from the transmitter, and it will start moving towards the transmitter at 120 kilometers per hour speed. And now we will see the effect of the packet loss simulation live on the Wireshark window. As you can see, as soon as I started the simulation, due to long distance between transmitter and receiver, we get very high values of packet loss, approximately more than 90%, which results in lot of TCP packets being retransmitted from the client to the gateway, which we can see in highlighted yellow packets on the Wireshark. As the distance slowly decreases, the packet loss also decreases, and we will see less and less TCP packets being retransmitted from the client to gateway.
so it went from 90% something now down to about 20 something percent.
Yes, we are about now 1.5 kilometers away, and the packet loss has already turned to 0. And as you can see, the retransmissions are almost next to none. So in this demo, we have showed the packet loss simulation using propagation modeling for the wireless links. We are able to support different physical and environmental conditions, such as the distance between transmitter and receiver, the environment types, and the weather conditions. We can also support different modeling methods based on the carrier frequency of the signal. All these parameters are easily configurable by user, and they can be varied from different connections or based on different links. All these features makes this packet loss simulator suitable and customizable for integrating in emulation of large ad hoc network. Thank you for listening.